Hello everyone. Today we will solve an equilibrium problem. Here the problem states in figure 35, which is this one, the bodies A and B connected by a cord and resting on smooth planes, weighing WA, which is the weight of A, equals 50 pound and the weight of B is 30 pound. The body A is acted on by a force in such a manner that the tension in the cord is 30 pound. So the tension in the cord is 30 pound. Here, if the normal reaction between B and the plane is 25.98 pound, what is the resulting force on B? From this situation, we can see that the A object and B object is connected by a cable, and we have to find the resultant of the B object. So we can assume the free body diagram here first. So we can draw FBD of B. Then we get something like this. Here the weight of the object B is vertically downward, which is 30 pound, and then the cable is in tension, so the cable is pulling it upward with a force of 30 pound. So we can write here 30 pound. And the angle between the horizontal axis and the tension here is theta. Here the another piece of information is that the B and the plane is 25.98. So the reaction of the plane with the B, so it will be 90 degree with the slope. So it will go in this direction, and the value is 25.98 pound. Here the angle between the tension of the cord and the normal force of the surface is 90 degree. So we can deduce that this angle is also theta. Then we will have to find the resultant. So for that we will have to first find the value of theta, which is unknown. For that we can assume that if a B object is pulled, either it will go downward to the slope or upward on the slope. So let's assume there's a downward pull which will negate the resultant of the upward pull. We are just assuming it, no concrete evidence for that as of yet. So we can write it as R prime, because it will negate the whole situation and keep it in place. Thus we will achieve the equilibrium. So let's find the summation of f of x, and taking the right word as positive, then we will get, for the tension in the cord we will find minus 30 cos theta. For the normal force of the surface we will get plus 25.98 sin theta, and for the unknown force which will be negating the resultant force we will get plus R cos theta equals 0. And if we solve it nicely and find the value of theta, we will get r prime cos theta equals 30 cos theta minus 25.98 sin theta. Then we can write r prime equals 30 cos theta divided by cos theta minus 25.98 sin theta divided by cos theta. Then we will get r primes equals 30 minus 25.98 tan theta. Then we will find the value of summation of f of y. For that, we will write summation of f of y upward is positive equals, for the chord we will get 30 sin theta plus 25.98 cos theta minus r prime sin theta minus 30, which is the weight of the B, equals 0. Now here we will also find the value of r, which will be r sin theta equals 30 sin theta plus 25.98 cos theta minus 30. Then r prime equals 30 sin theta divided by sin theta plus 25.98 cos theta by sin theta minus 30 by sin theta. Then we can write r prime equals 30 plus 25.98 cot theta minus 30 cosec theta, which is the equation number 2. So for the both equation, summation of f of y and summation of f of x, we have found the value of r. So let's write equation 1 equals equation 2. So we can write -30 minus 25.98 tan theta equals 30 plus 25.98 cot theta minus 30 cosec theta. Then we can put all the trigonometrical elements to the left and the numerical elements to the right, and then we get 30 cosec theta minus 25.98 tan theta minus 25.98 cot theta equals 30 minus 30. And let's break all the tan, cot and cosecs. Then we will get 30 divided by sin theta minus 25.98 sin theta divided by cos theta minus 25.98 cos theta divided by sin theta equals 0. Then we can write sin theta into cos theta. We will get 30 cos theta minus 25.98 sin squared theta minus 25.9. Okay, then we will get cos squared theta equals 0. And if we put sin theta into cos theta to the right side, it will be 0. Then we can write 30 cos theta here. Both have same values at the front, so we can write minus 25.98 into sin squared theta plus cos squared theta equals 0. We know that sin squared theta plus cos squared theta equals 1, so we can write 25.98 equals 0. So we can write theta equals cos inverse 25.98 divided by 30. Therefore theta will be cos inverse 25.98 divided 30. Then we get 30 degree. Since we have found the value 30 degree of the slope, now we can find the resultant with ease. Now let's find out the resultant. For that, we will solve it simply as any other resultant problem. So let's draw the free body diagram again. FBD of B. Then we get the weight of B pulls it downward, so it will be in the vertical axis, the value would be 30 pound. For the tension in the cord, it would be also 30 pound, and here the angle was theta, so we will write theta, and the normal force was pulling it 90 degree with the tension force, and it also makes a angle with the vertical axis, which is also theta. The value was 25.98 pound. So let's find the resultant. For that, summation of f of x, where it is positive at the rightward direction, equals, here we will write minus 30 cos theta plus 25.98 sin theta, and if we put the values in, we get 30 cos 30 plus 25.98 sin 30. Then the value of summation of f of x would be minus 30 cos 30 plus 25.98 sin 30. We will get minus 12.99 pound. For the summation of f of y, which is the summation of all the vertical forces here, we get 30 sin theta plus 25.98 cos theta minus 30. Then we get 30 sin 30 plus 25.98 cos 30 minus 30. So let's find the values. 30 sin 30 plus 25.98 cos 30 minus 30. We get 7.499, so we can write 7.5. So the resultant will be R equals root over summation of f of x whole square plus summation of f of y whole square. Then we get minus 12.99 whole square plus 7.5 whole square equals 12.99 whole square plus 7.5 whole square, root over answer. We get 14.999, so we can write 15 pound. So the resultant is 15 pound, and for the direction we can write tan theta equals summation of f of y by summation of f of x. Here we get theta equals 12.99 by 7.5 tan inverse. Value of theta would be tan inverse 12.99 divided by 7.5. We get 59.999, so we can write 60 degree. So we can show the resultant as here the value of f of x was negative and the value of f of y was positive. So the resultant would be in this quadrant and the angle between the horizontal axis and the resultant would be 60 degree. So we can say that the resultant was 15 pound and the direction was upward on the slope. That's it for this math. Thanks for watching.